Very much. So again, I'm Dustin Whittle. I'm a developer advocate that works on Uber's developer platform where I help our third parties and partners build moving experiences. But here I'm talking about JavaScript in a couple of different ways we use that at Uber. So one I'll talk about is on the back end, building microservices that power our core trip flow, on the front end, building web properties, and then to visualize data to help cities be able to better operate. But first, you probably know Uber by now. Push a button, get a ride. And Uber's motto is really to make transportation as reliable as running water, everywhere for everyone. And we've done that in under 8 years in more than 6 continents, 470 cities across 73 countries. We've done it by partnering with more than 1.5 million active drivers who do, on average, more than 5 million trips a day. And in last July, we completed our 2 billionth trip. And so just think about this scale in 8 years. It hasn't just been cars either. It's been choppers, kittens, ice cream, even Christmas trees. And so our goal is really to build the future transportation and logistics network platform. And so the scale has really evolved quite quickly. This is a visualization of Singapore on New Year's Eve, which is one of our most popular days of the year. And so if you can just imagine sort of the scope and what it's like to go from 0 engineers to over 14,000 employees now today in this time frame. We'll talk a little bit about how we use JavaScript across there. So it all started in June 2010 in San Francisco. It was our first ride in San Francisco, and by May 2012, we hit our millionth ride. We hit our billionth ride in actually December of 2014, I believe, and we launched our self-driving car project in February 15th, and our first self-driving ride by September 2016. And so along the way, we hired a lot of engineers, and those engineers wrote a lot of software. And when you're at a hypergrowth company like Uber, it really looks a lot like this image. You're moving super fast. Almost every week you're launching new cities. Millions of people are using our systems day to day to get around, and we can't even simply stop our systems even for maintenance. It's nearly like changing the wheels on a car driving 80 miles an hour. And so this is a graphic we use to often describe rewriting our dispatch system while serving traffic. And so to understand how we use JavaScript, you need to understand a little bit about how we scale the company and how the company is structured. And so we're organized as program teams and platform teams. And the easiest way to think about this is that program teams build products on top of technology platforms. And so program teams are like Uber Eats, Uber Rush, Uber Rides, etc. And so one of the things that we do is we invest heavily in building platforms to make it easy to get things done. And so I'll talk a little bit about how we use JavaScript to do that. But the reality is building a platform that interacts with the real world adds a whole nother level of complexity. The physical world's complexity is infinite, but we only have 64 bits and a 500 millisecond SLA. And so a lot of things can go wrong. And there's no safe time to pause. All of Uber's users are transactional. We have riders, we have drivers, we have couriers, we have eaters. So there's never a good time to take things down because everybody's always paying for a service, and we're a global company. And so in order to get to this state, we build more than 15,000 repositories across more than 3,400 microservices, open sourced over 260 of those, and with more than 250 web apps and 10 mobile apps. And so if you just think about the sheer scale of this, it's pretty insane. But Uber's ability to scale has come from high-velocity, hard engineering, along with autonomous teams and domains. One of the reasons that we use JavaScript early on isn't that it's just this amazing language, that it was at the right time. It was that a couple of engineers who were working on that problem decided to use JavaScript because they liked JavaScript. And then they started writing great code, started open sourcing stuff. They started to recruit people from the open source community who are interested in that. And so part of the evolution of JavaScript at Uber has just come from the community. So really our foundational services are designed for high scale and durability. And so we don't just use JavaScript at Uber, we actually use a few different languages. We're a polyglot engineering organization, and more of our services on the back end are actually written in Go. And so part of this is going to be how we sort of arrive to this conclusion. And so we use Go, Java, Python, and Node.js. But today we're going to be talking about JavaScript. So why JavaScript? It's really straightforward. It's a single stack for the front end and the back end. It's a simple interface with thorough documentation, and it lends itself to fast prototyping and quick iteration. When you're hiring many engineers, sometimes hundreds per month, how do you get them up to speed quickly? How do you onboard them into a new complex system? It needs to be very well documented. The language needs to be easy to figure out. Early on, it allowed us to avoid concurrency challenges. So it's a single-threaded event loop, so it made it asynchronous, nimble, and very flexible. But early on, a large part of this was simply that a couple of people worked on a team called Dispatch, then they wanted to rewrite something that was originally written in PHP MySQL, and at the time, Node.js was all the rage. And so today we only use Node.js for our web applications, but we still use a lot of JavaScript in the back end. And so we'll talk a little bit about how we got there. And so Uber was one of the first companies to use Node.js at scale. We actually prototyped the dispatch flow at 0.2, and it was running in production at Node 0.4. And at one point early on, more money flowed through Node.js as an application than in any other Node-based application in the world, until recently when PayPal started using Node everywhere. And so we were really early adopters. We invested heavily in the ecosystem. So we ended up hiring a lot of amazing engineers from the community. And so we chose Node.js for a few reasons. One, it's asynchronous I/O requests make it easy because it's non-blocking single-thread event loop. And when you have this microservice architecture, network I/O starts to become an issue. And so you need to be able to handle making many network requests very efficiently. And then Node.js and JavaScript in general has a really great community around it. There's tons of libraries and modules that make it very easy to not have to write all the code yourself. And so these were a few of the things that sort of led us to using Node and JavaScript really on our back end. Well, let's talk about 4 different ways that Uber is using JavaScript today. One, on our marketplace platform. Marketplace platform is what we call our dispatch service. This is really sort of the brain of Uber. This matches what's supplied to demand and really determines how a car gets to you and how you get to your destination. Our web platform, so our entire web presence is all based on Node.js on the back end and React on the front end, and then visualizing data. So we understand that every city is unique, and so to understand how cities work, we gather and visualize a lot of data to allow city managers to understand how traffic flows in a city, how supply and demand works, et cetera. And then we use Node.js as an interface to all of our external APIs for our developer platform. So let's talk a little bit about how Uber does engineering in general. So Uber invests heavily in developer productivity, and at a high level, we have our core infrastructure team, and the core infrastructure is really focused on just that. I don't want to have to worry about putting a box in a colo or a data center or having to worry about anything except for my application. And so there's an entire team that's focused on creating this great developer experience for internal engineers. And so there's the core infrastructure, and then on top of that, there's sort of the glue that brings it all together, and that's our developer experience team. On top of that, we have our marketplace platform. Again, we have 3,400 microservices, and I'll get into why this becomes a little bit tedious to manage in a minute. But the idea is that the marketplace platform is the central API that you can talk to that is how you access any one of these underlying microservices. So it's a single gateway. And this is the gateway that our mobile applications connect to access the third-party platforms. And so then we have our web platform that makes it easy to build standardized web applications with a JavaScript stack, our mobile platform that makes it easy to build iOS and Android applications, and then our developer platform. And so we invest heavily in all these different teams who are focused on a particular technical skill set and making it easy for other engineers to be productive with that. Again, when you're hiring really fast and you're scaling very quickly, you need to not just optimize for performance, but developer velocity. And so we have this cultural value of letting builders build. And really, this means to enable people to get out of the way to not block. And so when you want to launch a new service at Uber, regardless of the language, it looks like this. You send a proposal, an RFC, or request for comments to the entire engineering org. It has a high-level overview of what you want to build, how you want to build it, what the timeline is, and then key concerns. And then you start with scaffolding that's purpose-built for our stack. So much like Yeoman exists in the JavaScript community, we have our own version of this for different types of applications, and I'll talk about how that works in just a second. And then we want you to focus on just your application, not having to deploy and having to manage operational concerns. So you deploy with standardized global infrastructure in a standardized way. And then you should document everything because that's how you scale your team's knowledge. And so all the stuff I'm not going to talk about, but plays a key part of any service at Uber, and a large part of these are, some of these are actually JavaScript as well, is the foundation that you need to actually run a web application or to run a production service. A lot of things you don't normally think about, like how do you handle static assets or an asset pipeline? How do you handle communication between front-end and back-end services? Is that HTTP? Is it Thrift over T-channel or HTTP, et cetera? How do you handle translations, internationalization? How do you interface with data systems? How do you handle network compute, storage, logging, et cetera? And so all of this is baked in by default. And when I say that you start with scaffolding that's purpose-built for our stack, what I really mean is that you start with a application framework that already has abstracted all of these concerns away for you. So when you want to deal with translations, you just write a translation. You just write in the source language. Monitoring, alerting, security, compliance, it's all built in by default. And so let's focus on what makes JavaScript unique. And so a marketplace platform really looks like this at a high level. You have our iOS and Android clients. They talk to this gateway service, and then it talks to underlying services. And this is a really high-level version because the reality is that Dispatch looks a lot like this. And so again, we have 3,400 microservices, and this is actually a real diagram from our internal tools that show how the services are connected. And so one of the ways that we use JavaScript is to power this marketplace gateway. Again, the marketplace gateway, it's the only API that you need to know to interface with all the underlying services. And so all the mobile traffic from iOS and Android flows through this one gateway, and it acts as a router to the more than 3,400 microservices. And it's a single place for us to manage monitoring and documentation. And really, again, it's Uber's brain. So if you think about how it works, it's really about solving logistics challenges. If you have Uber Pool in the city, it's really a complex traveling salesman problem. How do I optimize for marketplace efficiency? How do I make sure that drivers aren't waiting and riders aren't waiting? And so really this becomes quite complex, very simple, very quickly rather. And then how do you combine different products? You know, if I have Uber Rides available in the city as well as Uber Eats, can I not mix that supply together with demand? And how can I do that efficiently? And so this looks very complicated and fancy, but really it all started very simple. It started as a monolith. And monoliths really aren't that bad at the beginning, but they quickly turn into a ball of mud. And so they optimize for development velocity of early stage projects, and they consolidate operational overhead in one place. When Uber started, Uber started as PHP and MySQL. And then from PHP and MySQL, moved to a mix of Node and Python. At some point, we started to run into database problems, and we sharded our database. We switched to Mongo, we switched to MySQL, we switched to Postgres, and then we switched back and forth. And a large part of the reason that we could replace these systems is because we started to break them down into smaller components. But like all web applications, they usually get started as a monolith. And again, monoliths aren't necessarily bad, but they optimize for developer velocity, and it only really works when a single team owns it. When you have hundreds of engineers committing to the same code base, you find that you run into issues. And so microservices apparently are a thing. But a microservice is really just a service that's focused on one thing. And one thing doesn't mean one API, it means one business domain. And so we started to break down all these, which was a massive Node.js service, into smaller components like supply and demand and pricing and different tools. And so we started to break these down, and we realized that there's a few things that come with migrating from monolith to microservice, and I think a lot of Node apps sort of start as a simple Express app and then get more granular from there. The first is clear ownership boundaries. So it allowed us to solve like who owns this piece of functionality. And when you're hiring many people, again, you don't always know everyone on the team, and you haven't worked with them. When the average employee is less than 6 months old, it starts to become a challenge to figure out who has domain knowledge and what. It also allows for product-specific velocity. Teams can move at their own pace. The Uber Rides team and the Dispatch team, who cares very much about stability and is going to iterate more slowly than a new product who's trying to launch something like Uber Eats Marketplace or Uber Rush. And so it allows each one of the businesses to move at their own pace. And it also allows us to solve scaling issues. Not only the underlying engineering teams, because you can just add more engineers in theory to a service and get a little bit faster velocity, but also allow to structure the company in a new way. And then training, documentation, and tooling around a particular service or a stack. But also, one of the best parts is it gave us language and platform independence. Teams could pick the right tool for the right job. And so often early on, when you hire a bunch of JavaScript engineers, everybody wants to use JavaScript to solve the problem, and that doesn't always make sense. And so we learned how to give people freedom and how to give them mature tooling at the same time. But ultimately, it's really about the reliability of the system. It made each service independent, scalable, and testable. But it also increases complexity. How do you figure out what to name a thing when there's 3,400 of them? Or how to discover which service does authentication when they're named random things? And so we had increased complexity because you didn't necessarily know what service to use for what functionality. You had to deal with eventual consistency. The data didn't all live in a single place. And then there started to become a performance impact. When you're dealing with many microservices, more than 100 services pertain to the core trip flow, how do you figure out what the performance problems are in distributed applications? And so we started to build some tools to address these. And then, of course, the operational overhead. For every service you're now deploying, you're now monitoring, you now need to document an interface to, et cetera. And so you have all the operational overhead that you had with a single application, now times 3,400 times. Okay. And so ultimately what you realize is that this leads to repeated code and repeated effort. Hey, actually, two different teams across different parts of the world are really trying to solve the same authentication problem. How do we communicate that better? And so Martin Fowler came up with this great graph that basically shows for less complex systems and for smaller teams, monoliths make you more productive, but over a certain period of time, the complexity and the size of the team increases, and so you need to decide when microservices have more benefit than risk for your team. And so some of the things that, for these challenges that we realized, these animations, I'll never go back. Okay, so one of the things that we realized is that there's some effort that comes with scaling node applications. And a couple of the challenges that we ran into early on was application level sharding. And so we built RingPop. RingPop allows you to run a RingPop client with a Node.js app and allows you to implement application level sharding. The idea is that either this node or set of nodes can either handle this request or not. And so when you think about the scale of Uber globally, not the size, we used to shard everything by city. And so Google has this library called S2. It allows you to break a sphere down into quadrants, and then you can basically make each one of those quadrants a shard. And this works great when cities are equally distributed, but New York City and San Francisco don't necessarily fit into a single shard. And so we needed a better way to shard our data model. And so RingPop is basically a Node.js application interface to doing sharding. And so it allowed us to implement sharding on a per city level and even to go more granular. And so the first thing we needed to do when we scaled our dispatch system is not all users live in the single location. And so how do we actually get everyone to route the traffic to the right place? The second thing we learned is that HTTP and JSON is expensive. It works for browsers and it makes sense for browsers. When you're communicating between many services internally, you can communicate more efficiently. And so at the time, Facebook had Thrift, but Thrift didn't have enough language support at the time, so we implemented T-Channel, and T-Channel allows us to talk to many backend services efficiently using our own RPC library. And then when you have complex distributed applications, for every service that you add, that's another network call. And so if you want to be able to drill down into performance problems, you need to be able to instrument your application and to see what user-facing interaction results in what series of network calls. And so we built a distributed transaction tracing library built on open tracing called Jaeger. And it was originally built on top of Twitter's Zipkin, and allows us to get visibility into complex distributed node apps. But not just node apps, Go, Java, Python as well. And so RingPop, again, is pretty straightforward. You have your application node instance, and then you have a RingPop client, and the RingPop client simply says this node can either handle this data or handle this request or not. And so in Uber's use case, this is, okay, can this node handle this city for this particular product and service? Yes or no? If not, route it to the right node that can. And so at a high level, RingPop makes it very easy to define what sharding means for your application and then implement it at the application level. And you can use this for more than just JavaScript applications, but the client and its server are implemented in Node. This is a Jaeger UI. Jaeger's UI really makes it easy to understand for a single request what were all the microservices underneath. And so when you're trying to figure out performance problems in distributed applications, Jaeger makes it very easy to get observability, to get visibility into exactly where time is being spent. And all three of these tools are open source, and you can use them in your applications today. And so ultimately, Node.js is just a thin scripting layer on top of C++. So all the normal Node.js tools, all the normal performance profiling tools for Linux work out of the box. So you should just learn how to profile applications. I think a lot of people come and ask for like, hey, how do I figure out what's slow in my application? Learn how to profile applications on Linux because all those tools just work in Node. We've also released tools for Node.js like Node CPU flame graphs using ptrace and some other tools, so check it out. But ultimately, all the big boy tools just work. So lessons learned scaling Node.js. Latency was too high for ultra-performant backend systems. The P99 for max latency. So when you have dynamic typing and you have dynamic garbage collection, it makes it really hard to get consistent results. So even if most of their requests are extremely fast, there sometimes can be a spike in latency. And what we realized on some backend services, the variation was just a bit too much for us. And so early on, it made it incredibly quick to iterate, but as the size of the team scaled, the developer velocity started to slow down. The problem with having many microservices is that it enforces a tight interface between the different services. And so at some point you start to realize that if I change the name of something, I either need to support naming it two things, or I need to make sure that that name gets propagated to all of its dependent services. And so by using languages that have static typing, it allows you to understand these interface issues or interface breakdowns much earlier at compile time rather than at runtime. And so what we realized is for teams, 100+ engineers working on marketplace platform, this really started to impact developer velocity. And again, it's quick to learn, but it's really easy to write poor quality code. When you're hiring new engineers, they just want to be productive, and sometimes that means they don't necessarily know the best practice, or maybe they just learned JavaScript a month ago. They don't understand some of the common traps. So it made things quick to learn, but easy to write poor quality code. And again, it allows you to move fast, but allows for sloppiness. And this can be both a benefit, but after a certain scale and a certain number of engineers, you need a tighter interface. And languages with static typing enabled that. And then Node has a great ecosystem of small libraries, but there are many that were immature compared to their Java or Go counterparts. If you look at the HTTP library that's in Node, it's notoriously inefficient. It should have just been written in C++, right, and exposed as bindings. And so how many remember the Node library that somebody removed from the internet and took down the whole world, right? And so it's great that we have this awesome community of libraries, but sometimes they get a little too small and a little too modular. And so now you have to start worrying about your dependency chains. And so we realized that some of these things just didn't exist in other ecosystems, and so we started to migrate away. Okay, we'll skip the animations. HTTP and JSON are slow. You should use RPC for server-to-server requests. HTTP is great for HTTP and JSON work well for the browser. They're inefficient when servers are talking between each other. After a certain age, microservices should become immutable. The reality is that it's easier to ask somebody to upgrade to a new service than it is to have them change the entire interface. So if you're going to be launching many services and those services have many dependencies, it's often better to just create a new service instead of having people migrate, have to rename things. Performance problems are difficult to debug without standardized dashboards. So as you build out these Node services, you really need to have observability built in. Jaeger solves part of that problem, but the other part of the problem is just having standardized uptime dashboards. And then having multiple languages, and I think this is a salient point, allows for team preferences, but it also segregates based on developer culture, what your personal beliefs are on different languages and tools. And so this also led to a couple of issues. But ultimately, everything is a trade-off. You need to be intentional. And so all of these, you can choose a different path, but again, it's about making conscious choices. When you're growing really quickly, it's easy to just go with the flow, but oftentimes you need to take a step back and make the right decision. And so Uber has a ton of different web properties, whether it's Uber.com, or if you checked out our self-driving cars, we just recently launched Uber Freight, so you can tap a button and book a load. to being able to sign up to drive, to get estimates, to order food, to be able to book cars on behalf of your business, to be able to share data with local city planners, and my personal favorite, developer.uber.com. All of these would have been built on different tool sets if we didn't have this web platform team. And so we have a web platform team that really uses a standardized node stack to build out web applications and provide a standardized UI component library that makes it easy to build web apps. And so without this web platform team, all of these would have a higher likelihood of security vulnerabilities, duplicated effort across teams, technical debt, and the UIs would start to look inconsistent. When we go to launch a rebrand, do I have to retheme every different web application, or can I simply upgrade my UI component library? And so this stack is built on Express, Node, and NPM. I think everyone's probably used this stack before if you do Node backend development. And on the front end, we use Facebook's React and we use Redux for state management. And so the Uber web platform is pretty straightforward. We use Nginx and Hot Proxy as our web front ends and our load balancers. We use NPM as our registry, Babel, so we can use the latest generation of JavaScript, Express, so we can use a great web framework, Redux for state management, React for UI components, and then Styletron for using CSS and JavaScript, and then ESLint to make sure everybody writes code somewhat similar ways. And so we extended this a little bit by adding our own internal NPM registry with caching so we can support private packages, and so that when people do things on the internet, it doesn't take down all of our internal services. We have our own Yeoman-like tool that makes it easy to bootstrap a new web application with all these defaults built in. And then we have customized middlewares around Express that allow you to handle auth, security, logging, internationalization, instrumentation, analytics, all the basic stuff. And then we have our own Bootstrap UI library that's built on top of React that exposes a set of standardized components to make it very easy to rapidly build web apps with a standard look and feel. And then we have our own RPC library that allows us to intelligently use HTTP or T-channel and Thrift, much like Facebook's Relay or Netflix's Falcor. And then a lot of this comes from a lot of the standardization comes from shared builds and test tasks that are built on top of Gulp. They make it really easy to do asset versioning, deploy our CDN pipeline, and then also do universal rendering on the server and the client. And so we separate our front-end and back-end services mainly because you can use the back-end services for more than just the front-end client. You can use it to expose an external API, an API to our mobile client, etc. And then we use React because we wanted to make it very easy to have very sexy websites that you don't have to maintain and build yourself. And so we have standard UI components that are optimized for performance and that have analytics, instrumentation, translations, and all the stuff sort of built in by default. All right, I'm running short on time, so I'm going to go even faster. Okay, so this is one of my favorite visualizations. This shows a day in the life of San Francisco over one day. And really what you can start to see is that the different traffic patterns across a city. We realize that every city is unique, and for Uber to work well in a city actually requires a lot of effort in terms of city operations managers understanding where supply and demand needs to be, and how that happens over time. And so one thing that we realize is that you need to make it very easy for these city managers, marketing managers, et cetera, to understand cities. And so we use JavaScript heavily to visualize data. And we've invested a lot in open source toolkits that allow you to take some of the tools that we built and reuse them. And so we use React Viz, which is really a React interface to building charts with D3. We use React Map.gl, so anytime you see a map in Uber, it's built on Mapboxes and React Map.gl. And then we use Deck.gl, which powers the visualization I just showed you. So it's a layered WebGL approach for for visualizing extremely large data sets. And then finally, we have Luma.gl, which is ECMAScript interface to WebGL2. Makes it easy to deal with 64-bit data. React Viz, again, every chart you can imagine made easy as a React component. Pretty straightforward. Check it out, uber.github.io. Deck.gl allows us to implement all of these sort of visualizations. It's a little bit hard to see, but if you mouse over this map, and you can see it at deck.gl, what you can see is pickups and drop-offs for a particular location in New York City at a given time. And so you can start to see different ways to visualize this data. And this is the same thing. This is density over time in New York. And so all of these visualizations require, these are millions of trips being visualized. And if you look at it, if you interact with it, it's very, very quick. It's highly performant. And so all of these are built with Deck.gl. check it out, deck.gl. I wish I had more time to go more in depth, but basically it creates a layered approach for doing data visualization, and it's extremely fast and supports visualizing millions of data points in real time. Again, LumaGL provides basic interface to WebGL, and that's what powers some of these other visualizations. There's a bunch of them available at DeckGL, but check it out. All of these tools, we invest heavily in open source. And so we try to expose all of this through our developer platform, and we also have a Node.js interface to all of our internal services. So the 3,400 microservices we have internally, we expose as 4 external services, and you can easily consume those via Node.js. And that is all I have for you.